Hi, everybody. Welcome to NASA's Airspace Operations Lab here at NASA's Ames Research Center in Silicon Valley. I'm Abby Tabor.
And I'm Tiffany Blake. And today we're here to talk about drones.
And specifically how NASA is working on a system to manage all of the air traffic from the many drones we expect in U.S. skies.
Here to talk about everything you've ever wanted to know about NASA's work in the area is Joey Rios. Welcome, Joey.
Hi, Abby. Hi, Tiffany.
Good to see you.
Good to see you guys.
So Joey is the chief engineer of the project we're here to talk about today. So Joey, tell us a little bit more about UTM and the work that NASA is doing.
Sure. First of all, UTM stands for UAS Traffic Management.
Okay.
And UAS is the word we use to describe drones.
Ah.
So we're trying to figure out how to allow drones to enter the low altitude airspace very safely, efficiently, and kind of fairly throughout the system.
Okay. What exactly is low altitude airspace?
So we're usually talking about 400 feet and under.
Okay.
And the reason for that is it keeps it away from, in general, it keeps it away from helicopters and general aviation, which would fly over 500 feet, but below 8,000 feet. And then you get to the really high ones, the big passenger jets that would be up even higher. So we're trying to stay down low with these drones.
Okay, so you won't be flying and then, see a drone across your wing.
You wouldn't want that if you're, no.
Okay, and so how will the drones be used?
Oh, there's all kinds of applications for these things.
Really?
Yeah, usually the folks that use these, they talk about them being suitable for the 3Ds.
3Ds, what's that?
Yeah, the dirty, dangerous, and dull jobs.
Okay.
They can be these could be very well suited to handle those kind of things.
Okay, can you give me a kind of example of maybe what a dull job is or a dangerous job? Or?
So a dull job might be, trying to inspect a road, right?
Okay.
So if it takes a couple of people and a truck and a camera and whatever else they do to inspect a road, that could take a while.
Okay.
Or if it takes a helicopter, that can get expensive. One of these can actually do this a lot faster.
Wow.
So that's one use for a dull job. A dirty job might be, spraying pesticides. Perhaps you can use one of these, get people away from that as much as you can. So yeah, those are two key ones.
Okay, and something maybe that's dangerous. That
Ooh, dangerous. Yeah, something folks don't think about is infrastructure inspection. So if I want to inspect a cell tower, usually we have to send someone up to climb that, right?
Right.
And actually, people die doing that every year, doing that job.
Wow.
So that ends up being a very dangerous job. So you can actually do a lot of that work with a drone. You can fly it up near the tower. You can take pictures and that kind of thing.
And so this seems like it's something that could be really beneficial. How come you don't have drones doing such jobs already?
Well, people have shown that you can do these jobs with drones already, which is great. But the question is, how can you allow a lot of them to do them at the same time, right? How can you do that inspection of the road and the cell tower and maybe have a police drone nearby and having someone taking pictures of a wedding nearby? How can you do all these things in kind of nearby vicinities?
Okay, I think you have like a cool car analogy for this to kind of describe.
That's one way to think about it is, with the road traffic that we have today, we have roads, we have lane lines, we have rules that everyone understands, stop signs, stop lights. That kind of infrastructure doesn't exist for these small drones right now.
Okay, and so what is NASA doing in order to create that infrastructure?
Well, it starts with a concept in general, but first what we like to do is think about drones just flying where they're supposed to fly in these like safe zones.
Safe zones,
yeah.
Okay.
Yeah, and I actually have an illustration I can show you over here on the screen.
Oh, cool. What's this?
So we're looking at this concept of these zones that I just mentioned. So if I'm someone that wants to fly a drone, if I could define a boundary that I'm planning to stay within, illustrated by these red lines here.
Okay.
If I can define that and I stay within it and I let other folks know what my plan is, then other folks can plan their red lines for running their operations within their boundaries. And if we can keep those separated, that's a first step towards allowing these operations in the airspace.
Okay, so what are some of the main principles for this?
So with the boundaries specifically, one of the first things we want to do is make sure that drones don't hit each other, right?
Oh,
so we don't want these hitting each other and falling out of the sky. That's bad.
Okay.
So there's a first step towards achieving that goal. Another thing is we want to make sure that drones don't hit manned aviation, right? We want to keep those things separated.
Right.
So what concepts and what data exchanges, what procedures have to be in the airspace to allow that?
Okay.
Another thing we want to make sure is that priority operations, like a police drone going to a scene or a fire drone heading to a fire, whatever it might be, that those have some sort of priority in the airspace, right?
Oh, wow, that's important.
If one drone is delivering a pizza to somebody and a police drone has to come through and perform something critical, we want to make sure that police drone can get through, right?
Of course.
So there's a way to preempt those kind of things.
Okay.
And the last one is that we can identify folks in the airspace, like people that are actually flying are allowed to be there and doing the thing that they're supposed to be doing.
Okay. Wow, that's really cool. And so will this system be used for just commercial drones or?
Yeah, it's a good question. So it is primarily designed for commercial operations.
Okay.
Hobbyists have their own set of rules, but that doesn't mean hobbyists can't leverage some of the things we're building, right? So hobbyists can actually use this to get some information about the airspace, to share information about what they're doing. So this is a possible use of UTM in the future, even for non-commercial purposes.
Oh, I'm sure they'll be happy to hear that. And also probably happy to see some of the toys you have here that you want to show us, huh?
I can show you some. So when folks think about drones, a lot of them think about stuff you could go buy to today in the mall if you wanted to go, or you could buy it online and have it sent to your house. So this would
Okay.
be a small kind of consumer level drone, four rotors on it, and you could fly it around your house or in a park or wherever you're allowed to.
So this is what people are probably used to seeing.
Most folks would think about a drone, they think about something small like this with rotors that flies. Exactly.
Nice.
But in our testing, we do try and look at all kinds of different drones. So
Okay.
here's a first example of a fixed wing. So this is a little more
Ooh.
like an airplane. It has less rotors. It actually just has one there towards the back.
Okay.
And this is the kind of thing where you could put something like a camera up in the nose, and you could put all the smarts here in the body, and you could perform some of those operations we were talking about earlier.
Okay, it seems pretty light. Generally, how much do drones weigh?
There's a big variety, right?
Uh-huh.
So there's really, really, really tiny ones. I mean, the kind that sit in your hand.
Oh.
And then there's very, very large ones, large as real aircraft. But what we're really talking about here for this system that we're defining is for things that are under 55 pounds. So these are called small drones.
Okay.
Yep.
Okay.
So these guys here are actually styrofoam wrapped in Kevlar. So they're really light and they're
really
tough.
light. Yeah.
Yeah.
That's cool.
And the next one here is very similar. It is, again, styrofoam wrapped in Kevlar. It's got a couple of propellers, and it can
Interesting.
perform some of those similar missions we were talking about with the previous one.
Okay. And so what would be an example of how you would use this drone?
Interesting about it actually is when you get started, you actually launch it by hand. So you actually kind of fling it like a shot put or a
give it a
javelin.
push,
Yeah,
right?
you get it going.
Into the air. That's cool.
Yeah, so again, you could probably put some sensors or some cameras up here in the nose, and you could perform whatever task you're doing. If it's taking pictures of a field or a road or a cell tower or whatever it might be, that's ideal for this kind of drone.
Cool.
But if you want to do something else like drop a package somewhere, something that has some weight to it, and you want to land vertically and take off vertically, you might need something a little closer to what we're looking at here.
Oh, wow. That one's cool.
Yeah, it is very cool.
Wow, it looks like a flying saucer.
It does. There's a reason it looks like this. It actually has the capability to land and take off from water, which is a very interesting
Really?
application. It doesn't have to do that, but it can. But this is the kind of thing that could drop off a package, for example, in a specific spot and then take off again from that spot and continue on its way.
Okay. And so this one seems very different from the others. What's the difference between having the multiple rotors and just the fixed wing drones?
Sure. So definitely the different applications, right? This one, given that it has more rotors, it can carry more weight, basically, right? You can carry more stuff. There's other characteristics that make it nice. Sometimes when they have multiple rotors like this, if it loses one motor, it could still maybe perhaps safely land, for example, where that's a little more difficult in a fixed wing if you lose a rotor. So there's different capabilities and different missions that make sense for different drones.
Wow. Okay, that's awesome. And for all of our fans watching online, we want to hear from you and answer your questions. If you have a question for Joey, please write a comment down below. And I'm going to invite my friend Abby back. Let's ask Joey some questions.
Let's do that.
Let's do that.
Okay. So, first question, Joey. Will NASA run this system by themselves?
Oh, no. Yeah, thankfully, no. The hard job of actually running this for real would belong to the FAA.
Okay.
But the way we're designing the system, part of the job actually falls on the industry side. So some of the things that the FAA would normally do for traditional aviation, industry will handle some of that work as well. But NASA, we're a research organization, will do the research in coordination with the FAA, and then the operational system will come from there.
Yeah, cool. We want to say hi to Matwez and Angel, who says hola.
Hola.
Greetings from around the world. And I have a question. How long has NASA been working on this? It sounds like quite a developed system by now.
Yeah, I mean, when we talk about it, it sounds like we've been doing this for a really long time. The concept was originally established around 2013 here at NASA Ames. It was socialized and became a real research activity for us in 2015, and we were doing our first flight test in 2015.
Okay, that's not really that long ago.
No, it doesn't sound like long. It feels like a long time for some of us, but yeah, we've come a long way in a short amount of time.
You've done a lot of work in 3 years, yeah. So we've heard quite a bit about what your system can do, is aiming to do. Can we actually see it?
Oh yeah, I would be very happy to show it to you.
Okay, cool. Take us there. We're heading now into NASA's Airspace Operations Lab, and this is quite cool. So take a look around once we get in here. You see a bunch of people working at terminals here, and up above you've got these giant touch screens that we're going to get a look at later. And Joey's down here ready to show us how the system works.
Sure, give you an example.
Yeah, I know it's software, right?
It is. A lot of what we're building is software-based. We want to build as much automation of the system as we can to help people make good decisions. So what we're actually sitting at here is what might be like a ground control station, somewhere that a pilot would be sitting to actually run an operation.
Okay.
This is just an example of one, so we can run simulations here.
Oh, I see, yeah. This looks to me like the inside of a cockpit on a plane.
Oh, yeah, you have a good
true?
eye. Some of the work that's done here in the AOL, the lab that we're sitting in now, is based on manned aviation.
Okay.
So we've taken some of the tools that have been developed in the past and reworked them for drone use.
Awesome.
So, yeah.
Cool. Okay.
Yep. So again, we're sitting here like a ground control station, so I'd be planning my mission. I could operate my drone here theoretically.
Wow, yeah. All right.
If I was doing a plan, I might want to do something here in this area.
All right. Where are you here?
Here, this is actually Napa, California.
Oh, wine
So,
country.
Wine country. So
Nice.
a lot of agriculture, a lot of vineyards. So if I wanted to take pictures of my vineyard, I might plan an operation that looks something like this.
Yeah.
Right. So this is a pattern over the field, for example.
Okay, that's the path the drone would actually fly?
That would be the idea, yeah. So
Okay.
I want to get good coverage and take good pictures, figure out maybe where I'm getting too much water or too little water,
Yeah.
those kind of things.
Yeah, monitor your fields.
So after I do my planning here in my ground control system, I want to send this information off to the UTM system, right? So simulating that, this button simulates that. I've sent off this information to UTM.
Okay.
So now the idea,
just like that.
just like
You
that,
plan it out
Boom,
on
just like that.
monitor. Okay.
It goes off, and what it does is it becomes available for folks that need that information. So this could be other people that want to fly nearby. It could be folks that live nearby.
All right.
It could be just folks that need to know about operations in that area.
Yeah,
So
what's
it's-
flying where.
Exactly.
Yeah.
You want to know that they belong there.
Okay.
So this is a different system now,
All
but it's
right.
showing the same data now that it's been sent to UTM. So
Yeah.
a lot of this can be shown, for example, on a tablet. Right. So you'll notice the same pattern here.
Yeah, yeah. It
This
looks
is the pattern that I plan to fly.
right over your vineyard, but
Exactly.
it's blue here. Does that mean
Yeah,
something?
here it's blue. Here, again, in this lab, we do a lot of different work. So a lot of the work they do is human factors related. So a lot of the work is like, okay, what color should things be?
Yeah.
And when should they change color like it just did?
Yeah, I noticed
Right?
that.
So it's become magenta.
Right.
And what that indicates in this particular software is that it was a planned activity, and now it's a real operation.
So the
when
drone's flying.
It is now. And actually, we can take a look if we go up to the big screen, take a closer look if you
Oh
want.
yeah, let's go.
All right. Yeah, so you can see it a little bit clearer on the big screen now.
Yeah.
You got your kind of an indication of the drone here,
Yeah.
a few little white trailing spots.
I see the drone. Can the viewers see that? Can you get in there?
And the white spots are just some of the previous position reports that have come in for this guy.
Okay.
And you can
Path.
see it's following the path that we had planned, right? So theoretically, someone would be sitting at a station like that, monitoring this operation, but those data would be coming into UTM for sharing throughout the system.
Yeah, yeah. So everybody knows what's going on.
That's
and
the
where
idea.
They can fly.
That's the idea.
Could there be other users flying right now?
There could be, yeah. So if we zoomed out a little bit, we may actually see that
Oh, yeah.
there's a couple more guys that have popped into the airspace,
Okay. Yeah.
right?
I
So
see.
these operators have decided, all right, I know about this operation, but I want to take pictures of my field, and I want to take pictures of a wedding or whatever I might be doing up here.
Right.
And I would share that information with everyone again nearby.
Okay.
And since we have some spacing
Gotcha.
between us, we feel like things are going well.
Yeah. That seems safe. So that one just turned orange.
Yeah, so things aren't going super well for that one up
Oh,
there.
no.
So you'll see that this one has actually exited its zone, right?
It's
We
gone.
talked about those safe zones before.
Yeah.
So in this simulation, this one has left its zone.
Rogue drone.
And again, that human factors thing we talked about before, we want to look out for those rogue drones.
Right.
We want to indicate to anyone who might be watching that there's something's going on there. And that's
Yeah.
why that color change occurred.
Yeah, I noticed it right away.
Exactly, so it flashes that for you. So in this system, when someone gets close to the edge, a lot like the game Operation. You remember when you
Yeah, the board game with the patient.
you
and
get too
the-
close to the edge and there's a buzz.
Yeah.
There's no buzzing here, but there's messages that go out.
Okay.
Right, so when you get too
Something
close
like
to the
that.
edge or you go over the edge, this turned orange, but also some messages went out to these operators.
Oh, yeah.
So they're aware there may be something going on with this operation. So
Okay.
they can make some informed decisions if they would like to just keep an eye on what's going on there. If maybe
Yeah.
they want to come home and land.
Okay.
They can decide how they'd want to
Yeah,
deal with that.
to stay safe. And what if it's not a problem with another user, but the weather changes and maybe a
Right.
storm comes
Right.
up?
Definitely possible. You saw how small these are. They're
Yeah.
very susceptible to winds, right?
Yeah.
So a little bit of wind can throw them off a bit. So the idea is that through UTM and through associated services, you would kind of get an idea of what weather might be in this area, along with maybe what the terrain is like or what other conditions might be like. And you can plan appropriately. And we want to build tools that help the operator plan appropriately. It's hard to make good decisions as a human a lot of times.
Right, right. if
So
you
give
don't
them
have
as many
info.
tools as possible. And if there's a little more wind, maybe you make the safe zone a little bit bigger.
Okay,
Right?
a
So
bigger
how do you-
buffer.
exactly, to make sure
Yeah.
that you stay inside there when you're operating, because that's one of the key principles that we try and get across.
Yeah, very cool.
Yeah, so that's how that works.
Interesting. Okay, well, I'm sure that people have questions for you, so
Sure.
I want to give them a chance to ask.
All right.
And if you're just joining us, we're at NASA's Ames Research Center talking about NASA's system for drone air traffic and how to manage all the drones in the skies. So let's see, Joey, what kinds of questions we might have for you.
Sure.
Okay. Sergio Ortiz is asking, is this system for use of hobbyist drones or just commercial drones?
So it's designed for commercial drones primarily, But again, that doesn't mean that hobbyists can't take advantage of it by learning what's going on in the airspace, making sure they're operating appropriately, know who else is operating nearby. So as you get more and more users into the system, the more valuable it becomes. So it is designed to get commercial operations in the air, but there are going to be benefits for hobbyists as well.
Okay, yeah, neat. Hello to David Holmes from Dallas, Texas, who sent his greetings. Mahmoud Saraf is asking, how long does the battery last? So first of all, do these drones run on batteries?
These drones, most of them run on batteries. They don't have to run on batteries. Right? So a lot of them, almost all of them are batteries. But they can run on more traditional fuels, gas and whatever else. You don't see those as often. And batteries last depending on the vehicle and the conditions.
Oh, yeah.
So it's actually very interesting. What you read on the box, if you buy a drone off the shelf, it can say, oh, the battery will last 2 hours.
Yeah.
But oftentimes that's not the case, right? So sometimes if it's too windy or if it's too hot, the battery could drain a lot faster.
Okay.
So you really want to know your machine before you go out and fly it,
Yeah.
especially commercially.
Yeah, that makes sense.
Yeah.
Joshua Mendoza wants to know, is this technology going to become a standard in the future?
There's a lot of pieces of it that need to be standardized in order for it to be really effective, right? So the question is, which pieces need to be standardized and who standardizes them? That's something we're working with industry with and with the FAA. So eventually, yes, you would see standards come out of this research. Not driven by NASA necessarily, but sort of seeded by NASA.
Okay,
Yeah.
yeah, cool. Here's a good question. Mark Brown is asking, can this be a problem for airlines? So you showed us examples in rural areas. What about near an airport?
Sure. So when you fly near airports, there could be different rules, right, than if you're flying in a field in Napa, for example. So maybe you need a little more equipage, maybe you need to share a few more messages, and there may be different rules for operating there. But the idea is that by sharing this information and making it available, you actually help everyone in the system make better decisions, including those airlines, right? So if without a system like UTM, it might be difficult for them to know if there's anything going on with small drones. So a system like UTM at least starts to open that up and allow folks to have knowledge about what might be happening.
Yeah, the picture that they all share to know what's going on.
Right.
Yeah. Jessica Areola wants to know, will there be a cost to fly your drone in the airspace system?
So we stay out of those decisions. In general, I think that folks want to make it as cost efficient as possible, but there aren't necessarily rules associated with that right now, and it may be dependent upon who provides some of these services. But given the fact that we're trying to allow access to the airspace, you should expect it to be accessible, right, including financially. So again, NASA stays out of those policy decisions. That's not something we would decide. It would come out of the FAA and industry coming up with an effective way to do that.
Okay. And we have time for one more at this point.
Sure.
How is this system different from the current FAA air traffic control system that we kind of know about for airplanes?
Yeah, with traditional air traffic control, right, there literally is a controller that is aware of each aircraft in the airspace. So a controller would be controlling a certain area in the airspace, a volume in the airspace. And they would be in contact with those pilots, for example, to help make sure everyone stays safe. If we think that there's going to be tens of thousands of more operations a day or whatever it might be, there's no way that system scales necessarily.
Yeah.
So we want to build in as much automation as possible, and we want to give some more responsibility maybe over to the operator side to make sure that it is scalable and not dependent on the FAA necessarily growing at a massive rate. Can we give some responsibility to that side on the behalf of the FAA necessarily? Yeah.
Okay, cool. Well, we want to invite you back later for some more questions, but we want to keep going with our tour.
Sounds
so
good.
since 2015, NASA has been conducting tests of this system in the field. And here to talk about that a little bit more is the project's flight director, Arwa Awais, who's right over here. Hey, Arwa.
Hey, Abby.
Thank you for joining
Thank
us.
you.
So tell us more about the testing. Why do you need to go out in the field to test your system?
So we usually go out to the field because we're trying to explore elements that are going to help us refine or improve our system. So basically putting our system to the test. And also we want to test some technologies and capabilities that are going to be needed for all of this to happen.
Okay, yeah, that makes sense. You got to put it through its paces
Exactly.
in the real world.
Yeah.
So how do you actually go about that? There's a lot of work to do. So do you break it down into phases, something like that?
Actually, yes. So we broke it down into 4 different phases.
Okay.
And each of them have increasing level of complexity. So for example, for the first and second phase, we looked at areas that were mostly rural or sparsely populated.
Okay, not too many people around,
Exactly.
complicate things.
Yeah, make
Okay.
it simple.
Yeah.
And then we were mostly focusing on visual line of sight operations, which means that the pilot or controller was still able to see the drone.
I see.
Yeah.
Yeah. Okay.
So for phase 2, we had some beyond visual line of sight
Oh, really?
operations. So that means that they're no longer able to see the drone.
Yeah, I see.
Yeah.
Okay, getting more complex.
Exactly.
Yeah.
And we looked at things such as infrastructure and agriculture monitoring, so those were some of our applications.
Okay, Joey talked about those earlier. Yeah.
Yes,
So
yeah.
that was phase 1 and 2, you said? Okay. And what happened in 3? That was this
So-
year, right?
Yep, so phase 3 we just finished in May. So for that we were mostly focusing on areas that are more suburban or moderately populated.
Okay.
So for that we also wanted to study technologies that would help us make sure that the aircraft stay safely separated from each other,
Right.
as well as separated from ground infrastructure.
Okay, that's obviously important.
Yes,
Yeah.
exactly.
And then next year is the last year, I think,
Yep.
phase 4.
Yes,
Yeah.
so phase 4 we're going to be concentrating on urban environments and also continue testing technologies that are going to help us enable these flights.
All right, definitely getting more complex.
Yep.
So where do you actually do that testing?
So we've actually been testing at 6 different sites. So we've tested at Texas, North Dakota, Alaska, New York, Nevada, and Virginia.
Okay, that's really all across the country.
Yeah, it is.
Why do you do that? Is there a reason to spread it out?
So we wanted to test at different sites because they each provide different capabilities.
Okay.
So for example, we did tests that are based on the geography and climate,
yeah.
infrastructure in that area, research needs. So we've actually tested near water and near farms. We've tested near airports and even in a military training area.
Okay, wow, yeah,
Yeah.
a variety of places.
Yeah, exactly.
Okay.
Yeah.
What is it like? Do you go out there actually?
I have actually. I've been to a few of the sites and I have some pictures that I can show you.
Oh, cool. All right,
Yeah.
yeah. Let us take a look. Okay, cool. Where is this one?
So this one is in Nevada, and this is a flight engineer that's prepping the aircraft right now. So usually the day starts with the group meeting to talk about what they're going to do for the rest of the day. Usually it starts pretty early because they want to try to get as much flight in before it gets dark and the winds pick up.
Oh, the winds pick up later in the day.
Yeah, exactly.
Oh, yep.
So they
Smart.
meet, then they go to the field to start setting things up and then start prepping the equipment like this engineer is doing
All
here.
right, cool. Okay, what else? Oh, well, that's a totally different drone. Like Joey showed us before, different varieties, right?
Yeah, so this is a multi-rotor
Yeah.
drone, and like we've mentioned, some drones are more capable than others. So some of them actually are piloted by remote control by an actual controller.
Yeah.
Other ones can be more automated, so you would just have a ground control station operator that's monitoring the display and the drone would be flying by itself. Some of them can be a mix, so they can be automated during flight, but then would require a controller for landing and takeoff.
I see. Okay.
So-
different abilities for different
Exactly.
drones. Yeah. All
That's
right.
the good thing about our system is that it can do all of this.
Yeah, it can handle all those. Cool. Okay. What else do you have to show us? Now those screens look like what we saw with Joey in Napa Vineyards. Is that the same part of the system?
Yeah, so this is something similar, and here we actually see the ground control station engineers monitoring the displays, as I mentioned earlier.
Yeah. Neat. What's next? Okay, I think I see a drone in the foreground, but in the background, that's a plane, right?
Yeah, exactly.
That's not a big drone.
No, no, it isn't. So for phase 3, we're actually interested in studying the interaction between manned and unmanned aircraft.
Okay.
So this was for one of those tests. So like you said, you see a drone in the hangar and then the Cessna, which is a small aircraft on the runway.
All right, nice. Oh, where's that? That's not Texas, I don't think.
No, that's in North Dakota.
Okay, that explains it.
Yeah. So like I mentioned, we want to test in different environments.
Uh-huh.
So in the previous pictures, you saw the nice sunny and warm weather in Texas. So here, this engineer is about to launch a fixed-wing drone, and he's actually standing on a frozen lake.
Oh, wow. Yeah, I see what you mean about different climates,
Yeah.
testing different things. Nice. What else? Where are we? Are we in a car?
So this is actually in the back of a van.
Okay.
So this is an example of a mobile operation center. So in previous pictures, you could have the crew, like you saw, they were in a hangar, right, with all their displays. But here, everything fits in the back of a van, and then they can just drive around to the different locations of the
Okay.
site.
So you can test anywhere.
Yeah, exactly.
Awesome. Nice. Do you have more? Oh, yeah. I know this place. This is where we are now, right? The Aerospace Operations Lab?
Yep,
Yeah.
it is.
Okay. And so do you always have people in here during the field test?
Yeah, so actually we had people here from beginning to the end for the 13 weeks of testing that
Oh, wow.
we did.
13
And-
weeks.
Yeah, exactly. And we have to be here because we need to monitor and support the field operations. And also we are trying to collect the data that we're receiving through our system.
Of course, right.
Yeah.
Are you doing long days for 13 weeks?
Yeah, actually they were really long because the test sites were across the country, right? So we were working with different time zones.
Yeah, of course.
So sometimes we were here as early as 5 a.m. and then as late as 4 p.m.
Oh man.
Yeah, we even tested on some weekends. But
Yeah. That's a lot of work. Did it go well though?
Yeah, I mean, like we said, like it's a lot of hard work, but it's really fun and it's very useful. And luckily, everyone here in the lab and at the sites were very dedicated and turned out to be a big success.
Nice, very good. So that is the third phase that you're describing, right? So there are 4 in total, I think, right? So that means next year is the last phase?
Yes, so phase 4, like I mentioned earlier, is going to be more an urban, highly dense environment.
Okay, more people, more stuff around.
Yeah, so one of the things we're going to be looking for is priority operations.
What does that mean?
So I can actually show you an example here.
Oh yeah, okay. This is an urban environment. Is this a real city?
Yeah, so this is Santa Clara, which is just south of where we are now at Ames.
All right, neat.
Yeah.
And so I see this pink or magenta box here. Is that one of those safe zones we saw earlier?
Exactly. So this is one of the volumes. And you can see now that there is actually a package delivery operation in progress.
Okay.
Over there.
There's a drone
It's
in
a
there.
little yellow,
carrying a package, all right.
But like I was mentioning, sometimes there's things that can happen, right? So what if a fire happens in a nearby factory?
Oh
like
no, I see it.
Here.
Smoke billowing out of those buildings.
Exactly.
Okay, what happens then?
So the fire department probably wants to send a drone to that area so they can survey the fire before the truck reaches there.
Okay,
right?
smart. So what do they have to do to make that happen?
So they submit a new volume, which is a priority volume. So you can see it right here.
Okay, so in the blue.
Yeah.
So that's the three-dimensional space where the fire department can fly?
Exactly. So this is the volume that they want to fly in.
Yeah.
But
yeah, wait, I was just going to point out that the pink volume goes right through that.
yeah, so yeah, they do intersect the volumes, but since the fire department is conducting a public safety operations, they have priority. That's what we mean by priority.
Ah, yes.
So that means that the existing package delivery operation has to get out of the way so the fire department can do its job.
Right, okay, well that's great to know that you guys thought of that and planned that into the system.
We thought of everything.
Right, excellent. That's so cool. Nice. So if that's next year, and that's the last year for NASA's testing, what happens next?
So at the end of 2019, we're going to be transferring the system as well as the requirements and recommendations that we've gotten through our testing as well as our industry partner participation. We're going to be transferring those to the FAA.
Okay.
And they're going to be doing more testing and then build the operational system. But we already have some components of our UTM system already operational now in the airspace.
Oh, wow.
Yeah.
Already.
And we're going to continue to roll out new features.
Oh, cool.
Yeah.
Nice. So little by little, we'll see more of the
Exactly.
system out there.
Yep.
Awesome. Cool. Well, I'm sure people have lots of questions about this, so I want to get to them, and I want to invite Joey back in and Tiffany back in to join us and take some questions from social. Do you have a question for us?
I do, actually. So we have the FAA, you have industry partners, and you have NASA. How does this all come together? What will the future look like?
Yeah, it's good to point out all those different folks that are involved. We started that from the beginning, and that was the idea that we wanted to involve folks from industry as well as the FAA to make sure that we're building a system that could be real and have buy-in from everybody that needs it in the future. So from the beginning, they've been providing input. Our partners actually help us field test all the photos that Arlo was showing you from our third phase. Those are actually partners operating out in the field under our prototype system.
Oh, okay.
Right, so they're the ones out there doing the work of actually flying. So they're building systems that talk to ours and doing those kind of things so that when we do start to hand off pieces to the FAA and they do eventually make their way into being operational, everyone is bought in from the beginning and has had a chance to give input and it becomes something that's real.
Wow.
Yeah, cool. Duncan Axisa is asking, how do the drones operate in and around clouds? We talked a bit about weather, but can they do that? Can they fly in clouds?
So there's a lot of rules about visibility, right? Where you can fly based on visibility. But since we are really talking about 400 feet and under, not as many clouds, though you can be 400 feet AGL and have clouds around, right? If you're near the top of a mountain, for example, right? That's possible, I guess.
Yeah.
So really it is about the capabilities of your vehicle, how well it knows its environment, and how well the pilot knows what the vehicle is doing. Usually that's taken care of by seeing the vehicle, right? Visual line of sight.
Okay.
When it's beyond visual line of sight, the clouds may or may not matter. It depends on that operation and the capabilities of the vehicle.
Okay. I would just say that we have clouds on the ground in San Francisco where it is
You can.
foggy all the time.
You can.
Another question here. Any estimate on the number of drones you're expected to see in the future or near future in the skies?
There's a lot of different estimates out there. In general, we stay away from picking a particular number. I think we just have the consensus view that there's going to be a lot of operations
right?
in the future.
Right.
So how do we make sure we're ready to handle that increased load that doesn't exist today? So whether it's this number or that number, I think in general people agree that it's going to be a lot. Right? So going with that notion, how do we build a system to support that?
Yeah. A question from Pedro S. Oliveira. What is the maximum height the drones can fly over?
So for our system, like Joey said, we're looking at 400 as the maximum for because it's doing low altitude operations.
That's right. Okay. 400 feet.
Awesome.
Interesting.
Well, we have a couple of comments here. Robert Bruce Phillips says, hello, NASA, you're doing great.
Thank you.
Yay.
Saying hello. And then also want to say hello to Oscar Velo. Hello.
Hello, Oscar.
So we have another question here. Robert wants to know, what industry does this feed into and what opportunities exist in the future for drones in the different industries?
Yeah, we mentioned some of the cases before, right, in terms of agriculture, infrastructure inspection, public safety, videography, photography. There's all kinds of things that are enabled through these kind of operations. So we try and involve as many folks that are interested in those areas to work with us, including manufacturers of the drones, as well as the people that may be supplying some of these services that don't exist. So there's a lot of opportunity for new businesses to sprout up to support such an ecosystem.
And working together.
And for folks that have existing businesses to operate in new and efficient and exciting ways.
So we actually had 30 different industry partners participate in our phase 3 testing.
Just in phase 3?
Yeah.
Oh, cool.
Yeah, that's a whole bunch.
Cool.
This is kind of related. Sergio Ortiz asks, have social events been taken into consideration? FPV drone racing is becoming a larger sport every year, or large concerts that use drones for video and photo.
Yeah, so we have kind of a comprehensive and growing list of use cases, right, or ways that people might use this. So the idea is that we're trying to take into account as many of those as we can as we develop these concepts and as we discuss them with the FAA. So yes, those are things that we are considering. For drone racing, for example, that may be as simple as setting up an area where you know that other folks shouldn't fly while the drone racing is happening. And there's a lot of other ways to deal with those kind of things within the concepts that we're building out right now.
Okay, neat.
Awesome. We have an interesting comment here. Or a question here. Brian wants to know, can the system support complex flight plans? A little bit different than what we've seen, a little bit more traffic.
Sure. Yes. So again, we try and design the system to support all the use cases we've identified, right? So as complex or intricate as those plans might be, so far we've been able to handle it with the descriptions of those plans that we've come up with, right? And when we find a case where it doesn't quite fit, we think about how we should expand what we've already done.
Right?
Exactly.
Right.
But right now,
the testing.
That's exactly right. So if someone wants to do a certain operation and it's just not handled by the way we built it, we'd have to revisit that. We've been actually very pleasantly surprised by the fact that a lot of the ways we've come up with to describe these operations have kind of stood the test of a few years now and haven't really had to have a lot of modification, and all these use cases could be handled. So yes, you can handle complex flight plans and operations through the system as we've defined it so far, and when it can't, we'll improve it.
Cool.
That's great.
A question from Guillaume Richier. Can we have a fleet of drones working together and managing tasks? That's a good question.
Sure you can. Yeah.
Would your system be able to help with that?
It can, and that's an open research question.
Yeah, I mean, like Joey said, that's possible because our system is supposed to be interacting with all of the different drones. So if they're participating in the system, they'd all have an idea of who's surrounding them.
Okay, yeah, that makes sense.
They can all work together.
Okay, nice.
We have another question. We have a question from Jacqueline Sanford, who is waving to us from Las Vegas. She's interested in knowing how the drones or the system will operate there, since they have a lot of tourist-like helicopter action there.
Sure. Yeah, so it really is about the environment you're going to fly in that determines what kind of requirements you might have to operate. So if you're not likely to encounter helicopters or other manned aviation, then that's a different set of requirements that you might have if you are going to have them. So a lot of the research that Ara was pointing out we already did in TCL in our third phase really had to do with detecting and avoiding and figuring out how to detect and avoid other aircraft, right? So what's the state of the art in that equipment right now, and what kind of procedures and requirements do we have to develop to support such operations?
Right.
Yeah.
Right.
Well, Dee Dee wants to share, I love drones, very efficient in this time of life. Definitely true. And Mike McWilliams sounds like a drone user. Are civilians ever going to get back out of sight flying? You mentioned testing beyond visual line of sight.
Yeah. So the commercial operations we're talking about would be run by civilians. So yes, that's what we're trying to enable in a regular way, is access to beyond visual line of sight operations. Right now, it's not necessarily the smoothest process, or it hasn't been in the past, to get a waiver to do beyond visual line of sight, for example. So this kind of system should hopefully evolve to replace the existing system of trying to get those waivers to be able to fly beyond visual line of sight. So the answer is yes. That's really what this system is all about, is letting folks get to beyond visual line of sight to do the things they need to do.
Do you want to mention the existing capability already, the lens? Maybe you talk more about that.
Yeah, so that's a good point. So
Yeah.
we mentioned that UTM isn't something that just is going to appear in the future as a complete thing. The FAA is starting to roll out pieces of this now and figure out what rules are needed to be in place for pieces of it now.
Over time.
One of the first pieces is this concept called LANCE, this Low Altitude Authorization Notification Capability. It's this thing that lets people fly nearby airports. That was one of the questions earlier.
Yeah.
Okay.
Right now it's limited to line of sight, but it does start to show how those data exchanges happen, how you have people supporting it through these data exchanges in a more automated way. So you're starting to see pieces of this concept starting to get into the airspace now.
Yeah.
Wow.
When you're doing this testing and collecting data in the field, what do you then do with it?
So like I said, when we collect data, we're receiving data real time through our system. And then we're also receiving data that's sent to us later on from the test site. So they collect data in the vehicle itself, and that information is uploaded to our sites. And then we combine this data, we look through it, and then we're going to do analysis
Okay.
to try to evaluate the test.
Yeah.
One of the key things is trying to figure out what you want to measure before you go out and fly. So before we go run these tests, we figure out, well, what pieces of data are we trying to collect, and what
question are you answering?
Exactly. So we try and do that as precisely as we can before we go out and flight test, and then we do that data collection and then do that analysis. And that helps inform what those requirements might be in the future.
Yeah. Cool.
We have a question here for Awa. Someone wants to know, how did Awa get involved in the area of this research, and this person wants to know, how can they get a job at NASA?
So it's actually interesting. I didn't actually study aerospace engineering in college. I
Really?
did civil engineering.
Oh.
But then a friend of mine was actually working at NASA. And they have a summer softball league here, so he invited me to watch the game one of these days, and I ended up talking to the person who ended up being a branch chief. And then like 2 weeks later, I get a call, and they're like, "Oh, we're hiring. Do you want to apply?" I'm like, "Okay." And I've been here for 10 years right now.
Wow, what a great story.
Softball is the
Softball,
answer.
coming to NASA.
Yeah, but actually, that might reassure Bubli Priya, who says, I have a dream to work in the NASA labs, but I only have a BSc in biotechnology.
Yeah.
Sometimes you can change paths, right?
Exactly.
Yeah. Right. Well, I think we have time for one more
One more question, huh?
Yeah.
Well, this is a question actually from J.D. Harrington. He says, are all UASs quad or hex or octocopters? He said the first picture looked like an RC aircraft. That's what he said.
Yeah, so it just those definitions are just based on how many rotors they have, right, for the vertical takeoff ones.
Right, the one that looks like
Right.
the flying saucer with all the
Exactly. So there's actually
rotors.
some exotic ones with varying numbers of those rotors. They all follow a similar design with a body in the middle and a bunch of arms coming out and a bunch of propellers on the outside.
Yeah.
So a matter of how many you put out there in terms of the capabilities you want and how much you want to lift. So yes, all those kind of things exist.
And
So
there
there's a
also-
variety always.
Yeah. So
Yeah.
there's also hybrid drones, which can be a mix of multi-rotor and fixed wings. So you would have rotors as well
Oh,
as
yeah.
the wings.
That's cool.
Yeah.
Joy mentioned that too earlier. Yeah, awesome. Well, we want to thank you guys both for your time and joining us today.
Thank you.
Exactly.
And we also want to thank you all for joining us online, and thank you all to everyone who actually submitted questions for us to answer today. Continue to follow us on Facebook and keep up with all of the exciting work we're doing here at Ames.